Okay, cool. So today we're going to talk about variables and logic. We're going to just kind of go over declaring and naming variables again. We talked a little bit about this the other day, yesterday. We're going to talk about logical operators, control flow, and then you'll have your homework. So control flow is sort of a central topic. So I'd put it like this. I want to do a little overview before we get into this. I like to do this overview of like what we cover in prep, and for people who are just starting out, you can feel like you're inundated with a lot of different information. And so the goal in prep is to give you all a complete set of tools. So like Tovio said, to get you to the point where you're dangerous, right? So where you can get things done, where you can produce working code. And some of that just takes practice, like thinking algorithmically and things like that. But basically, I could sit here and, I don't know, rattle off like 20 or 30 like topics in programming, different programming paradigms and different, development strategies and workflow organizations and like doing things like writing your own custom classes and blah blah blah, all this. But really, at the end of the day, if you want a simple, complete set of tools, you want to understand the types. And by the way, this doesn't just apply to Python. This applies more or less to almost any other language. I use the same rubric to learn other languages. So you want to know the types, and we'll dive into that more in a second here. The data types in the language. So let me be clear: data types, and we've talked about like int and float, right? So that's kind of what I mean. The types, the abstraction. So abstraction, for our purposes in prep, is going to come in two forms: variables and functions. These are different kinds of abstractions. Functions have a bit more complexity, although variables, you got to put variables somewhere in here, and this is where it goes. So really the takeaway from this is functions. So we could even just call this functions. So data types, functions, maybe we could say functions plus variables, something like that. And then data types, functions, conditions. More abstractly, we can call this control flow. So this is going to allow you to write code that executes under certain conditions. So you'll say, we'll deal with 3 conditional keywords: if, elif, and else, which will tell you, if some condition is met, then you'll execute some code. If it's not met, then you might execute different code, or you might just skip that whole thing and not execute the special code whatsoever. And then finally, loops or iteration. Yeah. So let's just do that. So these are the 4 things that if you get good at these, you have a simple but complete set of tools. Data types allow us to deal with a specific piece of information in a given form, right? So if we need to deal with textual information in text format, we would use a string. If we need to deal with numbers, we would use an int or a float. If we need to deal with, a binary condition or, something that has a true/false value, we would use a Boolean. So there's different types of data for different purposes, right? So understanding each type and how it works is based on its type operations. So if we think about int and float, type operations for int and float, and this is not comprehensive, but we'll go over a few here. We talked about addition, subtraction, multiplication, division, remainder, division, modulo, exponentiation, parentheses for order of operations, etc. Right? So these are things and features that are concerned with the number types, the numeric types, ints and floats, right? We could also put in some functions, right? There's the int function, and there's the float function, float function, and there's the bool function, which also applies to int and floats. And then there's there's a lot of other tools that we haven't gone over, that some are important to know, some aren't, but these are sort of the basic ones that we covered the other day. We could do the same thing for strings, right? So in here, when I'm thinking about type operations, really it's just a matter of like, what different things can you do with strings? What different pieces of syntax, or different kind of operations, different kinds of things can you imagine doing with strings, and how does Python deal with that? So some things we talked about are concatenation. There's repetition, repetitive concatenation, or like multiplication, basically, where we can have like hello times 2 equals, or gives back hello with a space at the end, right? Things like this. So these would be other examples of type operations for strings, right? So we can think of every type having a set of sort of operators and functions and various operations, whatever, that apply to that type. Maybe uniquely, maybe that also applies to other types, but at least apply to that type, that we can utilize with that type and make use of that data type, right? So these are some ways that we can make use of strings. These are some ways that we can make use of ints and floats. And obviously we talked about bool in there as well, and we're going to talk about more about booleans today. I really never do know where to put variables in this whole thing, but technically it goes under, and I'm using specific names, I should be using more general names for this. This should be called abstractions. Let's see. Abstractions. There are various. So abstraction means that you abstract away some of your code. You write your code and you hide it behind something that makes it simpler for you to deal with, so you don't have to deal with some large body of code or a complicated math equation. You can just use a variable name or a function call, just a simple thing in lieu of a complicated thing, right? So this helps make our code manageable. It helps make our code sane. It saves us from having to rewrite the same code over and over again. If there's some algorithm that you want to use with slightly different inputs and slightly different variations every time, and you use it like hundreds of times in your program, you can write it once as a function, or you can save it in a variable and use that function call or that variable however many times that you want. So I want to be clear here, functions and variables are not the same thing. You'll see that variables are very simple. Functions have a bit more moving parts, but they're not terribly complicated at all. So, but they are technically both abstractions, and they help us containerize code for reuse later. Control flow conditions lets us execute code or avoid code dynamically. Dynamically meaning under a given condition. So a condition is any part of your code that evaluates to a Boolean. So a condition is any part of your code that evaluates to true or false. So remember we talked about the Boolean operators, like 6 equals B, right? And then maybe B equals 6, right? So this is what we call an expression. This is what we call a statement. So B equals 6 states the fact that B is equal to 6. So it states it, right? This is a statement. A statement does not give you back a value. And there we'll kind of be getting more into this idea of what an expression is and what we mean when we think about, or when I say something has an output. So this does not give us an output. This gives us an output of true or false, right? This expression, Python will look at this and say, oh, well, I have a number here, which is the value of 6, and a variable here, which also points to the value of 6. And it's either, since I see this equals operator, I'm going to check if these two things are equals, and then if they're equal, I'm going to replace this with true, right? So this expression, I can just replace this with true in my code, right? If B was not equal to 6, if B was 7, then I could replace this with false, right? Now, obviously, in our code, we're going to be writing dynamic code, so we don't know what B is. B is equal to something. So we want this to be dynamically true or false based on the value of B, right? So this allows Python to figure that out, but either way, it's going to turn it into either true if they're equal or false if they're not equal, right? So that's what we mean about an expression. So yeah. So control flow uses those kind of statements, which we call conditions, and a condition is any expression that gives back a value of true or false, or that evaluates to true or false. Iteration / loops. We're going to cover two kinds of loops, and then some other non-loop iterators. There are the two main tools that I want you to use for iterators. And we're going to get more into this in future lessons, but they're for loops and while loops. And for loops have some advantages in terms of like writing a clear and manageable, elegant solution, but they are slightly less powerful than while loops. What I mean by that is while loops are capable of solving a certain set of problems that for loops can't solve, right? Or can't solve well. So while loops have an advantage in terms of what we call power, which means versatility. Any problem you can solve with a for loop, you can solve with a while loop. But while loops are harder to manage and they're prone to getting into infinite loops, whereas for loops, you don't, unless you're really trying, you don't really have to worry about a for loop getting into an infinite loop. I believe in more than a year of teaching and working with students, I believe I've only seen one person accidentally get write a for loop that was getting into an infinite loop. I've done it on purpose just to do it and be like, oh, I wrote an infinite for loop. But while loops, you're kind of constantly battling, making them not just run forever. And for loops, it's generally pretty hard to get them into that mode. So we're going to talk about iteration and repetition through the lens of loops. So for loops and while loops. And what these allow you to do, it may be fairly obvious at this point, but iteration, repetition, loops, whatever you want to call it, these will allow us to repeat certain parts of our, repeat certain parts of our code dynamically, however many times we need it to repeat, right? So a lot quite a shocking amount of algorithms look like start with something neutral or empty, repeat some process for every element in a collection of elements, and modify the neutral or empty thing you started with by collecting elements appropriate to the process that you repeat in the loop, right? So that's what I just described. You might know as an accumulator pattern, and that's a really central pattern to problem solving in coding. And I forgot to write this thing for functions. So again, so functions encapsulate a process. I might have spelled that wrong. So okay, cool. So this is not entirely comprehensive. I could fill each of these out, you know, like I could write a lot more type operations for ints and floats, and obviously these are just 3 of several other types that are built into Python that we're going to talk about. You know, we could talk about different uses of functions and different kind of the anatomy of a function and when to use them and how to define them versus calling them and things like that. Control flow is simple. It's a simple idea that gets complicated quickly. It's a small mechanism that has ways of combining it that get complicated fairly quickly. It's not terribly bad. It's something that you definitely can get used to, but it's just, you know, so we could go into like how to write and when to write certain conditions. And then we could, with loops, we could basically talk about different kinds of accumulation, different kinds of algorithms that involve loops and things like that. So this is not, you know, the be all end all, fully formed, fully fleshed out version of this, but I wanted to do this because I think this sort of makes it bite-sized, right? Like at the end of the day, you're just learning about data types, you're learning about functions, you're learning about control flow and conditions, and you're learning about iteration. So these are the major topics that we'll be covering and diving into deeper. And hopefully that makes it more approachable rather than like, you know, feeling like it's this vast kind of soup of knowledge that seems intimidating or something. Okay. Cool. So let's actually dive into variables now. So you can think of variable assignment as giving a name to something so that it can be accessed later by different parts of your program. So if I want to save the result of the operation 4 times 7, I can save that in a variable called, we'll just call it num. So the name part here, the name portion of the variable is called the identifier. And we get to name the identifier whatever we want. We could call it foo, we could call it bar, we could call it bass, we could call it just give it some random name. We talked about this earlier. Generally, you want to give it some kind of descriptive name. Take a second to think about what would be a good name for this thing that would help me think about this later on down the road. What would be a name that like accurately describes this? So this is a number. It doesn't play any special role in my program because literally I'm just writing a variable that's equal to 4 times 7. So just calling it number is sufficient, or num is sufficient for here. There's sort of a collection of pretty standard variable name sort of what it's the word, shorthand names for things. So like we'll say a lot of times I'll use num instead of number. If I'm going to make a list, I'll use LST instead of LIST. the reason for this is that list is actually a built-in keyword in Python. We don't want to use that, but list, lst, flt for float, things like that. There are conventions around calling certain things, you know, in certain contexts, giving them certain names that are single letters. So we'll use like the letter I to describe a number in a range when we get into for loops. In general, unless there's a convention around using a single letter variable name or a single letter identifier for something, you will, if there's an obvious convention around it or it's obvious from the context of what you're doing, that's fine. But in general, I want you all to avoid doing this thing where, and I see a lot of people just do this where it's just everything's A, B, C, D. This makes confusing code quickly. So yeah. So be forewarned, give things a good name, something that helps you think about it, and that'll be descriptive as to what it is. Cool. Just looking through, looking for questions here. Looks like everybody's good. All right. So yeah, let's talk about this. We talked about this is the identifier, and the single equals is what we call the assignment operator. This assigns the result of this expression to this identifier. Remember earlier I called this a statement? Well, this statement actually involves an expression. I talked about an expression as something that gives us back a value, right? So 4 times 7 gives us what? 28. 4 times 7 evaluates to the number 28. So this expresses the number 28. So this expression is then captured in this identifier, and this whole thing, even though it involves an expression, this whole thing is a statement, because, you know, if I printed this out, this is actually going to be an error. Oops, I'm like, why does my output look weird? Okay. This says num is an invalid keyword argument for print. So this is not behaving like we think it's gonna. So I can't print out a statement, but I can print out an expression, right? So this is an expression. It expresses the value 28. This is a statement because it just says, hey, I'm just stating that for the expression of or whatever 4 times 7 expresses is equal to num. I'm just stating this. But then whenever I use num is itself an expression because it gives back a value. So I can print out num. So I can't print out the whole statement, but I could print out the expression itself, or the formula. I could print out the formula, which is an expression, and I can print out the identifier, which expresses, or the variable which expresses the value itself. And this is a good way. If you want to test if something is an expression, just throw print around it. If you get an error, then you know it's not an expression. It doesn't express a value. So print will print out anything that expresses a value. Any data type we can save into a variable, and any data type we can print. Declaring variables. So that's what I'm doing here. I'm declaring this. I'm declaring the existence of this number equal to 4 times 7. So this says variable equals value. This should, in my opinion, this should say identifier equals value, and the whole thing is called a variable. I'll usually just, when I'm using a name somewhere, I'll just call it a variable. But technically the name portion is called the identifier. So no need to print to see the result of the assigning variable. Okay, so here's another thing. We can assign two variables at once on one line. If I want x to equal 10 and y to equal 20, I'll say x comma y equals 10 comma 20. So x is the first identifier. It's going to be assigned to the first value. Y is the second identifier assigned to the second value. Now you might ask, well, okay, great, but why not just do this? You know, how is that different than just saying x equals 10 and y equals 20? It's not. It just saves you a line of code. It's just a different way. If you preferred to do it that way, you could do it that way. There are times. So what's happening here, and we will come back to this. This is, well, I don't want to. Yeah. There's something else going on here that we'll see syntax in other places that looks like this sort of A comma B syntax that you know, thing one, thing two, thing one comma thing two, where each item is getting a value sort of dynamically in this way. And we'll talk more about that later. So the mechanic behind why this works will come up again later. For now, it's just if you want to declare two variables on one line, you can do that. And this, to be clear, is not just for two. If we wanted to do z, we could also do if z equals 30, then we could do that. Cool. All right. So I know I already kind of said this, but I'm just going to read through this because it's really worth getting this idea in there. So you should strive to give your variables well-defined, succinct names. Variable naming conventions are covered in PEP 8. So there are standardized naming conventions that already exist. I highly suggest reading up on them. Like I said before, once you're comfortable with the programming language, the hardest thing that's left is variable naming. It's like there's just, you know, every developer and every programmer, you know, knows the feeling of like, oh, I know how to solve this problem. And it's like, you know, it's coming to you all in a rush and it makes sense right now and you got to write it down and you're like, oh, I know what to do. I know what to do. I know what to do. And you're trying to write it down before you forget it. And then you're like, what do I call this thing? Oh, I forgot what I was doing. And it like all floods away in that moment. You're like, oh, wait, what do I call this variable? What do I call this variable? So like understanding good naming conventions, you know, like you want to reduce the amount of friction there as much as possible. And part of that comes with practice. You know, there are certain things that I just, you know, certain simple assumptions that I make now. Like if I write a function that takes in a list and as an input, and I have another list in the function somewhere that I, you know, another local variable in that function. I can't call them the same name. So usually if I write a function that takes in a list, I'll call it like list in just by default. Or often I will, or maybe I'll call it array, ARR for array, and then I'll call the other one LST for list. So there's little tricks like that you'll pick up with time, and then just like little good habits that you'll get into to make things consistent, right? So Python by convention uses snake casing. So if you have multiple words, we separate the words in your variable name with an underscore, and that convention is called snake casing. So we just replace the spaces between the words with underscores. So this is a variable, all underscore separated. So there's some reserved words that can't be used for variable names. All right, yeah, well, I was gonna screen share my browser and go through this. I'll let you go through this on your own. Let me see, can I just really quickly, I want to reserved words. Okay. So these are words that Python will not let you use as variable names. Now there's another sort of category of this. And sorry, I do see a question here. I'll get to that question in a second here. So there are words that if you try to use, like if I try to say return equals 10, Python is just going to be, it's just going to yell at me. And we can see the syntax highlighting changed here, right? So it says invalid syntax. What if I say del equals 10? Just invalid syntax again. So there are a number of keywords that it just won't let you use. Def is another one. And there are a number of words that it will absolutely let you use that you should not ever use, right? So if I wanted to say print, notice my handy dandy print function down here, this great, wonderful function that allows the things that I want to be visible in my terminal, it makes them visible in my terminal. Well, unfortunately, Python will just let you use the word print, P-R-I-N-T, as a variable name. So print equals 57, totally legal. This is totally fine. This is absolutely fine to do. It just overrides the print function. So I no longer have a print function. Instead, I have a variable named 57, named print that is equal to 57. And then it gives me this error, int is not callable, because it thinks I'm trying to use, it sees this variable called print here, and it sees me trying to use it as a function, and it's like, well, this isn't a function, it's an integer. You just made it an integer, so I don't know how to call an integer, I only know how to call a function, so it's giving me an error because of that. So there are a number of words that Python will allow you to use that you want to avoid using. So any built-in function name, you obviously you don't want to use as a variable name or as a name for one of your own functions, because it will override that built-in name. So in general, you don't have to be too careful about that, but just keep it in the back of your mind, like don't call a variable print. We talked about int, right? Don't call a variable int, right? If I say int equals equals hello, right? Obviously, I should call that string because it's a string. But if I did this, and then I tried to cast print int, what do I call this? Int 6.7. Right? I try to cast this float as an int. Well, I just lost my int function. Another thing here is int is not only a function, but it's a type identifier. So if I have any code that is, is checking the type of something to see if it's equal or not equal to an integer, I can't do that anymore because int is now a string, right? I use this as a variable name or as an identifier to store a value. And it's unfortunate, in my opinion, that Python allows this. I wish if you tried to say print equals, something. I wish if you tried to override a type identifier or a built-in function that it would yell at you, but unfortunately it doesn't. So be forewarned. So there's those reserved words list that will tell you the words you can't use. And then as you go, you will learn the words that you mustn't use. Okay. Boolean operations. Okay, so we talked about these a bit, right? So I can see if one number is greater than another number. So 4 greater than 2. Oh, I'm sorry, because we're back to expressions. I wanted to take this question. So there's a question here. Does every statement need to be on a new line? I believe that is the case. I believe, I don't know, you will have expressions that are comprised of other expressions and statements that are comprised of other expressions, but I'm not sure you have statements comprised of other statements. I don't think you do. So I believe it would be accurate to say that every statement goes on its own line. Yes. I want to say I'm like 99% sure this is the case, but I'll watch out for that. I haven't really, it's been so long since I went over that. So, okay. So this expression, 4 is greater than 2. Go ahead and put it in Slack. True or false? 4 is greater than 2. Acceptable way of answering this question is to write it in Replit really quickly and print it out and then pretend like you got the answer. That is completely acceptable. But because it's not pretending, you're using the language to help you solve problems. Yes, cool. But y'all know this one because you know that 4 is larger than 2, right? Okay, so 4 less than 2 is false. 4 equals 2. Let's do this. 4 not equal to, greater than, and then we can do greater than equal, less than equal. So these are our Boolean operations. Or our Boolean operators. Oops, come on. We got the lag. Okay, logical operators. These are similar to Boolean operators, but we call them logical operators. Excuse me. Sorry about that. So the logical operators are and, or, and not. So these are somewhat similar to, now, I forgot to mention this, with the Boolean operators here, I think I mentioned this the other day, where I was saying when I see these, I see a Boolean. When I see this, regardless of what the numbers are, obviously I'm literally seeing numbers and operators, but I try to see the expression as the thing that it evaluates to, as the thing it expresses. So these expressions all express Booleans, and I know that because of the operator. These operators, if given valid operands, which we're doing here, will express Boolean values, right? So the same can be said for not, and or. However, their inputs, their operands, have to themselves be other Booleans. So if anybody's ever taken a formal logic class, a truth table will probably look familiar to you. So let's write truth tables for all of these. So you can feel free to do this along with me. So we have, let's write the truth table for and. So if and has an input of true and true, its output will be true. if it has an input of true and false, excuse me, true and false is false. False and true is also false, as well as false and false is also false. Let's try to just be nice and formatted. Okay, cool. So true and true is true. True and false, any combination of and that involves false is going to be false, right? So where this comes in handy is when you want to say, let's say A equals 10 and B equals 7. Yeah, where this comes in handy is, imagine if I have two expressions that I want to know if both are true, right? So A equals B and A greater than 30, right? So I'm going to surround these in parentheses just to be clear what the operands are. So the operands, and I'm just going to give us extra space. Okay, so the operands to this and are in the parentheses. So A equals B is the left-hand operand to the and it's like some kind of weird tongue twister. And the right-hand operand is A greater than 30. Obviously, both A is not equal to B, and A is also not greater than 30. So this expression evaluates to false. This expression evaluates to false also. It doesn't matter. As soon as we know that one of these evaluates to false, we can see that the whole and system evaluates to false. So as soon as one of these is determined to be false, you can just say, okay, so this whole and is just going to evaluate to false. So if we run this, we'll see false. Well, we'll see true, false, 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 false. Oh, and a bunch of other stuff too. Let me comment this out. So this is really the use case. Obviously, we if we just put in true and false here, then we kind of don't need the and. We just have the values. But you can see the same thing is happening, right? So this expression gives me back either a true or a false. This expression gives me back either a true or a false. And these are the operands, true and false, are the operands for an and here, right? So I can put in expressions that give me true or false as the inputs for the and. Okay, so let's write this a truth table for or and not. So or, so true or true is true. True or false is true. False or true is true. False or false is false. We should see true, 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 and false. So if either of the inputs into or are true, the output is also true, right? So it's kind of an opposite to and. So let's look at not. Well, not is really easy. If we print not takes in one operand. So we can just say not true. Who wants to guess what not true is, right? Not false. Not true is false. Not false is true. Cool. So we can also combine these. Now, when it's often the case that you'll want to do something, let's write a truth table for not and or NAND, right? We could say not and. Sometimes it's called a NAND or NAND gate. So if I do this, what have I done? I've done not true and true or false, right? So this doesn't negate this whole thing. In this case, this is going to negate just this first condition, right? I'm going to call this a condition even though it's a literal value of true or false, right? So there's this way of doing it, but this will just invert. So not just inverts a Boolean, right? If you have a true, it turns it to false. If you have a false, it turns it to true. So you can think about what would the truth table for this look like. Not true is false and true. So false and true is false. Not true is false and false is also false. Not false is true. So true and true is true. Not false is true, and false, true and false is false, right? So that turns into this table. So this is not quite a NAND table. This is not a proper NAND table. So I want this to be clear, right? So if I wanted to invert this whole thing, I can put it in parentheses. I can say the operand for oops. Sorry, let me be okay. There we go. All right, so what I'm saying here is that the operand or the input for not is whatever is expressed in these parentheses. So what this says is this follows PEMDAS, right? So the parentheses evaluates first. Okay, so it's going to evaluate true and true is true. Not true is false, right? Okay, true and false is false. So not false is true. False and true is false. Not false is true. False and false is false. Not false is true, right? So notice, remember back when I said or is kind of the opposite? So notice it's not truly the inverse of and. It kind of sort of is in that, like, if there's one false in an and, the result is going to be false, and if there's one true in an or, the result is going to be true. That's kind of an opposite, right? But if I just straight up invert the value given by and, I get a different output pattern than or, right? So I've had some people say, well, why not just use and NAND and you don't have to use or? The reason is that they're logically different. So these give us different logical values. And this is sort of, I wanted to make this clear because a lot of times, and I see a lot of people do this, where they want to invert the whole, the result of a whole and or a whole or system, right? This being the system. And to do that, you have to put parentheses around the thing. And the reason that this has to be the case is because we have to leave open the possibility that we want to just invert only one or the other input, right? My preference in general is to make everything painfully clear in terms of what I intend to do with lots of parentheses. So if I were actually going to do this, I would do this. I wouldn't put parentheses around something like this because it's only one thing, but I don't know, why not? Why not? Maybe it makes it look more consistent or something. We could do that there. So again, using lots of parentheses to say, the input for not should be whatever this was, right? Even if you're not sure whether you need the parentheses or not, if you want an easy, safe assumption, just put them in there, and it could save you a headache down the road. Cool. So you can see these are three simple logical operators, but we already have some complexity developing. So it's important to understand them in terms of what they do, not necessarily every nuance about how we can derive from how they combine, because combining these three simple operations is that's the foundation for anybody who knows about like how silicon chips are made, that they're made out of like NAND or NOR gates. Yeah, because they're simple tools that can do everything. So I believe, yeah, they are a Turing complete system, all unto their own. But so don't worry too much about those. We just need to understand them in a simple way. Cool. Like I said, right? Here's sort of a complicated, more complicated expression. So what's the, oops, I gotta be careful about showing the solutions there. You saw nothing. Okay. So what's the result of this? Is this going to be true or false? You can go ahead and copy paste that into your REPL. Take a look at it. Now you could look at this and try to brain it out, and really just like knock your head against it. That's fine. I mean, it's good to like look through code and understand it. Or you can get Python to do the hard work for you, and then you're programming. So. Cool. Seems like we have a number of answers here. I'm not going to do the full 2 minutes for this. So I do have this printed out. But we'll walk through this. So how could we go evaluate this? Well, one thing is we could just print it out. Now, this might feel like cheating. I don't consider it cheating. I consider it using a programming language, which is why we're here. So in the course of asking these breakouts, it's absolutely acceptable. I don't consider it cheating to figure out, well, how do I get Python to tell me? How do I get Python to tell me this information? Because that skill is going to save you, like learning how to get Python to tell you what you don't know. That's a really central skill for any programmer. So, any Python programmer. So learning how to get your environment to do the work for you that's the thing. That's the trick, So, so this does give us true, or obviously, I say obviously, but yeah, let's also brain this out and talk about how we would analyze this. So I'm just going to break this onto multiple lines here. Even though this is broken onto multiple lines, notice my opening and closing parentheses are still present for the print. This is valid to do. You can do this if you want, although it's not typical. So this will still print out. So let's look at this. So I see a lot of parentheses here. So the first thing I want to do is find innermost sets of parentheses. So right here, I see a set of parentheses. And right here, I see a set of parentheses. So I'm not going to worry about this and. I'm just going to worry about these innermost parentheses here, right? So these two groups. So this first one, true or false? Well, it's an or, and I see a true, so it's true. True and true, it's an and. Excuse me, true and true, it's an and I don't see a false, so it's also true. So true or true is true. Excuse me. True or false is true. True and true is true. Therefore, this is true and true, right? We can look at this and we can say this turns into, oops, true and true, right? Which itself just turns into true. So this whole portion, where does it end? This is why I like spaces. It's not where it ends. This is where it ends. That's why I like spaces in my code. So this whole thing I can just replace with true, right? I can just replace it with true. It evaluates to true. It expresses the value true. So I can just replace it with true. Just get rid of it. It's confusing. True is less confusing. So not true is false. Not true is false. This says not false in parentheses. Now it doesn't need the parentheses. So the not false is true. So this says true and true or false is, okay, so that's true and true or false. So true, I think it doesn't matter. There's an order of operations here that I forget. I think it's not evaluates before and evaluates before or, if I remember. So I'll evaluate this group first. True and true is true. True or true is also true. So this whole thing I can replace with true. Cool. Yep. And then I think, where do we talk about? I want to get to, right. Yeah. So this is the part here. Order, logical order of operation. I would call this order of operations for logical operators. We'll cover these bitwise operations in a second. We don't even really use them, but we just want you to know that they're there. So not evaluates before and evaluates before or. So that's important to know as well. Okay, and this is just a bit, the solution is basically just the same, you know, just a breakdown of what I just did in here. All right, so bitwise operators. So these are, we don't use these that often, but it's important to know that they exist. You may never use these after this, or you may not use these for a long time after this moment, but we have bitwise, not, bitwise, and bitwise or. Not bitwise not is the tilde symbol. It's on the same key as the backtick key, as I mentioned before. Ampersand for bitwise and then vertical bar, which is usually on your under your right pinky on most keyboards. For me, it's below my delete key, above my return/enter key, to the right of my bracket keys, square and curly bracket keys. So that's vertical bar. That's for or. Yeah, so if you see these, don't worry about them. They might not exactly do what you expect them to do. There's one that is kind of useful, which is the exclusive or, which is actually the bitwise or. So it's, for some of you who are familiar with logic gates, you might have noticed that I didn't mention XOR, right? So you can think about this as XOR, as an XOR gate, right? So if I print true, true caret true, we're going to get false, right? So the truth table for this is going to be different than the other ones. But essentially, we don't tend, I mean, if you want kind of a more complete, you know, set of tools with the logical gates, I mean, here you go. But this is also, let's look at this. Okay, let me do my formatting. False, true, True. False. Okay, so if we just say not equals, it's the same thing. Right, so this behavior is sort of already included in not equals. So if you need an exclusive OR operation, you can use not equals. That's what I do. Doesn't come up that much, to be honest. At least it hasn't for me. Not to say that it won't for you in your future coding endeavors. Perhaps it will. So those are your bitwise operators, and this talks about XOR. Okay, cool. So let's get another breakout. What do each of these return? I'll paste this into Slack. And I'll put, I'm going to put, where are we on time? I'll put 3 minutes on the clock. There you go. Have at it. Oh, I noticed a couple of people are asking in the main channel if I pasted it. So I did paste it in the thread here. Oh, this was actually a while ago, it looks like. But so I pasted it in the thread. If you go up a little bit where it says, right now it says 77 replies, that'll change, that number will change. That's where all the class activity is. And to the person asking if I pasted it, go ahead and just post something in that thread once you find it, or just let me know if you can't find it and I'll help you find it. Just post like a thumbs up so I know you found it. All right, cool. So we got a lot of good answers in there. Da-da. Let me get my screen share back up and running here and we'll get going. Come on. Okay. Or you know what? I'm sorry. We're about halfway. Why don't we take a 5-minute break? We'll reconvene at 19 after the hour. Cool. Let's get started again. Okay. Good time to change gears here because we're getting into control flow. Now, like I said, we're going to go over a number of topics. We're introducing a big one here, right? We looked at a few operations and things for Booleans, which are important, and they're going to help us understand control flow and conditions. So this is the beginning of one of the big ones, control flow. So control flow, I always think this term kind of sounds cool. It makes it sound like it's something like really complicated and like dynamic and like there's a lot going on there or something, like all the things involved in control flow and your control and the flow and the, I don't know. It literally only means conditions. It only has to do with like writing dynamic code. Sometimes we call it dynamic, meaning that it'll execute under certain circumstances, code that will execute under certain circumstances and not under other circumstances. So I find these kinds of charts to be a bit confusing myself, but what this is saying is, our program flows into a condition. If that condition is true, literally the Boolean value true, if that expression that evaluates to true, we execute the code in the condition. If it's false, we skip that code in the condition. The way we can do this is with if statements. Okay, so let's do something simple. We'll say a equals 10, and we'll say if a is less than b, and we'll say b equals 20. So a less than b, is a less than b true or false? True, right? A is 10, b is 20, a is less than b. So this is true. So this condition is true. So I will call this kind of expression, I will often call this kind of expression a condition. Any expression that gives back or evaluates to a Boolean value is a condition. Any expression that evaluates to a Boolean value can be a condition. So we can say if it's true that a is less than b, then let's just print a is less than b. So this will print the string a is less than b. It'll print that. It'll print that if it's true that a is less than b, which it is. If a is less than b is false, so if I make a 30, so a is 30, b is 20. If a is less than b, if 30 is less than 20, 30 is less than 20 is a false statement. It's false that 30 is less than 20. So if 30 less than 20, print a is less than b. So if I run this, let's be fancy here, fin. So we know that the program is over, it's done running when we see the fin, right? So notice how this code does not execute anymore, right? So we're no longer running this print a is less than b, right? So I might say I can combine this. So I have code that I want to run if a is less than b in here. So for all the code that I want to run, if this statement is true, what I do, notice I have this colon at the end of the line that tells me that the head of my condition is over. I'm done checking the condition, and that I'm on to the body. I can have any arbitrary code, and I can have as many lines of code inside this if as I want. And the way that I know that I can distinguish which code is going to be executed, if that's true or not, is by tabbing it in underneath that code. So Python uses what's called white space formatting. So it formats the code with spaces, with white space. There are 3 white space characters. There's what you think of as space. There's the new line character, which makes a new line. And then there's the tab character. This looks like a tab character. It's actually, I have my editor set up, and you'll set up your editors like this too. That tabs will insert 4 spaces rather than a tab character. So this isn't actually a proper tab character. Python requires that the indentation be done with spaces, not tab characters. So for whatever that's worth. But at any rate, it's white space formatted, which means that the white space matters. So the way that it knows to execute this code in particular, if that's true, and not this code, is that line 88 here is indented under the if statement, whereas line 90 is not indented under that if statement, right? So as soon as something is dedented, meaning unindented, or unindented, right? As soon as something is unindented, the body of that if is finished. It's complete. If I have more code that I want to put in there, I can't say print more stuff, right? This is actually going to be a syntax error because I already ended the body of that by unindenting some code underneath it, right? It's already over. So if I want everything I want to do in there, I have to include in that indentation level. And then once things are unindented, it's over. So this is the code that I want to execute if it's true. What if there's special code I want to execute if this statement is false? Well, I mean, I guess I could say if not A greater than B, I could just do like the in first condition, but that's a little clunky to say, like if not A less than B. So what I can say is if this is true, do this, else, okay? So else is another conditional keyword. So if is a keyword, else is a keyword. So these are keywords, and these are a couple of keywords that like I can't say if equals 20 or something. That'll give me an error. So else is all the code that I want to execute if A is not less than B. So I could say A is not less than B. Maybe I could say A is, why don't I say A is greater than B? Oops, I don't have Slack up here on my phone. Apologies. Hopefully I didn't leave anybody hanging there. Come on. So some may see that you know, there's a certain scenario where A is neither less than nor greater than B. So, you know, might want to do something else. And we'll get to that in a second as well. So if the expression A is less than B is true, then I want to run this code. If that expression was false, then I'll run this code under the else, right? So else is an alternative to the prior condition being false. If that prior condition was false, then it's going to do what I have listed in the else. And again, I can have as many lines of code in here as I want. So let's just run this. I'm going to use this little minor comment switch here. Excuse me. There we go. Okay, so I can switch between these two quickly now. So if I make a, sorry, this is confusing. I don't need to do that. Okay, so if I make a, when a is 30, right? It says a is greater than b and then fin. When a is 10, now it says a is less than b. And you might ask yourself, well, you know, why have the else? If you want to run this code when a is not less than b, why not just have it outside like this? So this is going to run no matter what. You can see this is going to run under all circumstances, whether or not a is greater than or less than b, right? So we need that else if we want to run it only when a is not less than b, only when this condition is false. So this is our condition is true code, and this is our condition is false code. And it can be any code. It doesn't need to just be a print. We can assign variables. We can have other if and else statements, things like that. So notice else does not take a condition because the condition that bears on the else is still this one, right? So yeah. So what if they're equal? What if they're both 20? A is 20, B is 20. What's my code going to do? Go ahead and put it in Slack. What's my code going to do? There's what it's going to do, and there's what it should do. It'll print fin. It will print fin, yep. So A is less than B is false, right? So if this condition is false, you know, this isn't checking if it's greater than B. It's checking if it's, you know, else is going to run this code if this expression is false. And that's it, right? Even if, you know, our consequent for this else is to say that it's greater than, but that's actually no longer accurate. Right, so it's going to say greater than even though it's equal. So we have another construct which is elif, E-L-I-F, which means we can check another condition here. And I can say elif A is greater than B. So elif says, okay, so if the previous condition was false, check this condition instead. Elif is short for else, being the previous condition was false, and if, meaning check another condition, right? So this says, given that the previous condition was false, let's check another condition and check if it's greater than. So now this is more accurate, right? So this, in this case, it doesn't print anything because it says, if A is less than B, print A is less than B. If else, given that that previous expression was false, that previous condition was false, check if A is greater than B. And if it is, if this condition is true, then print A is greater than B. But notice nothing prints, right? And this is actually what we want in this case because, you know, we don't want to run either of these. So it's better to, I mean, maybe better to just do neither one. But we can also have, we can also determine that A is equal to B. So we could have a place to print A is equal to B. Oh, I have greater than them. Why do I have that? Oh my gosh, I can't believe I just caught that. I was even looking at those strings. I was like, why is it so much longer? Oh my gosh. Okay. A is equal to B. Okay. So A is equal to B. So I can say else. Okay, so now I know if A is not less than and A is not greater than, then the only possible thing left is that it's equal to B. Given the constraints that we assume both A and B are numbers and are capable of being equal, you know, if they're one is a string or something, then we're kind of out of hope, but yeah, this will work. So A is equal to B, right? And now this will print if A is less than B. And I'll just do 3 conditions here, right? So less, greater, and equal. Right, so we should see less, greater, and equal. Cool. And I apologize here. There were a couple questions about the breakout, and I kind of moved along quickly after that around our last breakout. So there's this thing. I've deliberately avoided talking about this because I don't want to add extra confusion, but people are, I forget that our material integrates it right away. Cool. So there's this thing about truthiness and falsiness. I find this, I don't know, I find this to be kind of annoying, honestly, that the languages that incorporate this, I kind of like stricter, kind of clearer rules. But an empty string is considered falsy. If I cast an empty string as a bool, I'm going to get false. If I cast a string with literally anything in it, it can be a single white space or any amount of characters, or, you know, an entire sentence or whatever. It could like have literally anything in it at all, then it's going to be true. So that's what's happening there. So when you have something that's empty, generally empty things are considered falsy, whereas things that have contents are considered truthy. With numbers, if we do this with numbers, numeric values that are equal to 0, which is 0, and in float land, it's 0.0. Any other value, positive or negative, is going to be truthy, right? So -1, or negative 0.1, or 1.1, or let's do 1.0, negative 1.0, right? So the only 2 falsy values here are these. That's it. Literally any other numeric value is truthy. So it's this weird thing where things can be understood as Boolean values that aren't Boolean values. This will actually work in conditions as well. So I suggest, my personal preference is to just not utilize this mechanic. But you will see it sometimes, like num equals 10. If num, so remember I said an expression is any value that any expression, or excuse me, remember when I said a condition is any expression that gives back a Boolean value. That's how I want you to think about it, right? Technically, a condition can be other things. Technically, in my opinion, I don't know. I find that this can be kind of confusing, and it's just like, if a number, like this kind of shouldn't work in my opinion, but it does. So if I print, we'll just say num is true, apparently. Oh, am I getting? Oh, okay. Was major lag issue? Okay. Num is true, apparently. Okay. So if I run this, num is going to be, we're going to see num is true, apparently. So this works. If num is 0, right? So sometimes this can be like a quick, easy way to determine, okay, if I have my number equal to 0 or not equal to 0, then I have special code that I want to do for that. Or if I have a string is empty, right? So if I wanted to run special code if the string is empty, so I could say if not string. But what I prefer to do for the sake of consistency is to say if string equals empty string. Same thing, much more clear, right? This to me spells it out. If string is equal to empty string, here's what I want to do, right? So this is clear. The other one is like, it's using truthiness and falsiness. So it's this whole mechanic that's built in for this purpose, and I don't know. I guess some people like it, but it's something that I tend to just try to avoid. And I kind of want to get. I know that was in our breakout, but I kind of want to just. I'll probably go in and like remove that breakout or edit it with something else. So apologies for the confusion around that. Okay. To be clear, that's not something that, if you're a beginner, it's not something that I want you to like focus on understanding, but it does happen. Now you know about truthiness and falsiness. It's out there, but I'm going to be avoiding it. Okay. If, elif, and else. So we've talked about these a little bit. Let's just see. Let me just read through this and see. Okay. So we looked at a scenario, this A equals B thing. We looked at a scenario of using if, elif, and else together. So a couple things. I'll see people do this. I'll see people, you have whatever, code in your problem, and they'll be like, oh, and they'll just start with an elif. I mean, I get it. I remember being a beginner and doing this as well. So, I'm not trying to shame anybody. And I know people are going to do this. It's fine. But just to prevent, just so we have this established now, you can't have an elif just hanging out without an if before it, right? So I can't say elif A elif A A equals B, or whatever, A greater than B, because there's no if. I mean, what is the L part an alternative to? It's just like this L, the EL in the elif is short for else, right? Else means given that the previous condition, what previous condition? Given that the previous condition was false, there's no previous condition. So you can't start chaining conditions together. You can't start it with anything but an if. Right, so we have to, if we want to check a condition, we have to start that with an if. When you have elif and else following in a conditional chain, we call that a chain. And we can call each block, we could call it a block, or we could call it a clause. I'm going to call it a clause just to avoid any confusion with blockchain. This has nothing to do with block and chain. Blockchain. This is just, there's a block of an if or an elif or an else, right? So I'm going to call each of those a clause. Right? So this is a clause. And I can chain these clauses together. I can chain these together with if, elif, and else, right? So I can have as many elifs chained together as I need. So I can have if, elif, 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 else. I can have as many elifs in the middle as I need. I can only have an elif after an if or another elif, right? Because it has to be an alternative to the prior condition, right? So if I have an else, that means that chain of conditions is over. And if I want to do more condition checking, I have to start a new if. I have to start with a new if. I don't need to end a chain of conditions with an else. It's not necessary. I can have a solo if. We looked at this, hopefully that's proof, right? I was showing you if in isolation before I showed else and elif. We can have an if and an elif. That works too. But if I use an else, that chain of conditions is done, right? So it's not, we can't have an elif or another else after an else, right? Think about that, right? You have an else. Okay, so if all prior conditions were false, do this. If the previous and all prior conditions in this chain were false, else, here's the code that I want you to execute. If you have another elif or an else, you're saying, okay, so if the else was false, else doesn't have a condition. Else relies on the prior condition as its condition, right? So we when we use an else, that chain of conditions is over. Valid ways of doing this, a solo if, an if followed by another if. This is essentially just starting two independent chains of condition checking that have nothing to do with each other, but there are times when you need to use consecutive ifs, and there's times when you need to use if and elif, right? If, elif, or I'll do else. If, elif, dot, 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 meaning as many other elifs as you need. If, elif, else, and if as many elifs as you need, and else, right? So these are sort of valid combinations of conditions. Invalid would be any set of conditions that starts with elif or else. So we can't just start with these like this. If we start a new one, we have to do an if, right? But it's valid to do any of these, to have conditions checked in any of these patterns, right? And to be clear, this is sort of an exception to the rule because this is two chains of conditions, two or more. Whereas all the rest of these valid examples, and I'll mark these as valid. Oops. Why is that happening? That's weird. Okay. So of all the valid ones, this is one chain of conditions. This is one chain of conditions. This is one chain of conditions. These are all one chain of conditions. This is just describing multiple chains of conditions, right? So let's also explore this a little bit more like this. When I have, and I'll just take my A, B code here. When I have an if and an elif together, when I have an if and an elif together like this, when this, or let me put it more generically. When I have conditions chained together, meaning elifs and elses, when they're chained together, they are a single system. And what that means is one and only one of the bodies of code in the conditions is going to be run, right? So there is no scenario here where both of these will run. It's never going to happen because not because A can't be greater than and less than B. That's also true. A is either greater than or less than B unless we change it, right? But what if I change it? So if A is greater than B, make print A is greater than B and reassign A to be equal to 5, right? Well, then this condition should be true, right? Because A is now less than B. Or, well, okay, it was less than B anyways. Let me fix that. Okay, so A is 30, B is 20. If A is greater than B, print A is greater than B and reassign A to, I'll use 10. Reassign A to 10, right? So now the expression A is less than B is true. But this elif, remember, L is an alternative, else is an alternative to this condition, which was already true. So since this member of the conditional chain was found to be true, Python will not even bother checking. It won't even look at the other conditions. It won't execute the code. It won't attempt to. So this will only run this one thing, right? So if I want both of these to run, because now it's possible that both of these could be true because A changes its value in the previous block. So it's possible that both of these could be true, right? So then I need to make these separate chains. And in this case, this is a chain with one link, right? Each a chain with one link. That's what I should call them, links, right? So these are like, This is one link in a chain, and this is a different chain. This is a different link in the chain. Okay. So it's important to know this. It's important to know when you need to use consecutive ifs rather than if and elif. If both scenarios can be potentially true, then you need to use two ifs. If only one of a certain set, if only one of two, one of five, one of three, whatever conditions can be true, then you need to use if and elif and else. If you want one of the conditions to execute no matter what, then you end it with an else, and then that way you say, okay, well, if everything else, you could have 100 elifs above it. So if everything else was false, then do this instead. And if you don't have that else there, then it's possible that you get through all those elifs and none of the conditions were true, and you don't do anything special, and then you're just back out of that chain of conditions. So again, so these are simple tools, and you can see that there's some complexity can build from these. The important thing is I see people kind of try to rush through conditional logic, and take a breath, just take your time. There are not many useful axioms that tell you, well, when you have this kind of problem, then you know that you always want to do an if and an if, or when you have that kind of problem. The safe rule of thumb here is you need to just think through every problem, which is not really a rule of thumb, right? Each problem's unique, and you'll develop a hang for it, but it can be a little tricky. So just take a breath, take your time, and go slowly. Also, don't be afraid to run your code. The worst thing that's going to happen is you're going to get an error. So you already know how I feel about errors. They're very good things. Cool. All right. And this is just giving some examples. We have another breakout. All right. Well, this is a 5-minute breakout. So we're inside of 5 minutes till end time. So I'll just wrap up here. Go ahead and just do the breakout for part of your homework. You can share your answers in Slack in the main thread or in the class thread, whatever. So yeah, we can wrap up here for today. We got through a lot of material. Big takeaways are Boolean operations involving equal, less than, greater than, and the logical operators, and conditions as well. So if, elif, and else. Taking your time to construct those. Go ahead and play around. Don't be afraid of errors. Get all the errors as many times as you can, and then you will be unstoppable. So yeah, we'll wrap it up. You're free to go. Stay on for questions. I'll hang out. Let me stop the recording, and you can unmute your mic.